The only problem with GC if you're a C programmer is that C doesn't do that for you. It doesn't register all the local variables with a garbage collector. Conservative garbage collection is a way around that. Conservative garbage collector for C would let us write this blue box as the actual C code, and somehow the garbage collector is going to find T, for example, or other variables. It can't do that precisely, but it knows how the machine works. It knows that local variables go on the stack. It knows that global variables, static variables, are put in a particular place that it can find from the ELF format, for example. And so it is possible to write to some degree, non-portable garbage collector that breaks through those abstractions and automatically finds the local variables and other things. Right? And it can do that only approximately, though, and that's where the conservative part will come in. So suppose that when we've allocated nodes, they all end up in this range of addresses, hex 789.800 all the way up to 788.000. When we run out of memory in our current set of chunks and we call collect garbage, the C stack is going to look, say, like this, something like this. So collect garbage is going to do some work, but collect garbage is actually going to look at the stack to figure out where the local variables are on the stack. And then it'll register those as roots just before it does the work that we saw already. When collect garbage looks at this stack, then it'll just look word by word to see whether they could possibly be pointers stored there. And in this first slot, the number 2, that's not in our allocation range. So the garbage collector will not try to treat this as a reference to any allocated node. Similarly, the 1 here. Also, this number here, this looks like an address that's on the stack. So it's not pointing to an allocated node, it's pointing to something else on the stack. On the other hand, the second slot here, that does look like a node pointer. Now, the collector cannot be sure, the conservative collector cannot be sure that this is a node pointer. It could be a number that you were about to print out after doing some multiplications or something like that. But that's the conservative part of the conservative GC. It'll assume that because this number looks like it could be a pointer, that it actually is. There's another complication here. We have a pointer, but this is clearly not the pointer to the beginning of a node record because it's an odd number. It's not suitably aligned. Depending on your configuration of your conservative collector, it might just ignore this. Clearly that's a number instead of a pointer to a node. Or maybe you're doing pointer arithmetic in your program, and this especially happens if you're allocating arrays and traversing them, in which case the garbage collector has to recognize any pointer in range and shift it to the beginning of the object as needed. In that case, it's some extra work for the conservative collector to be able to take an arbitrary pointer in the allocation range and find the beginning of the object, something that our allocator last time could not have done, for example, because it relied on knowing where the headers and footers are relative to a given pointer. We're going to ignore that and just say that if it's not properly aligned, we're not doing pointer arithmetic in our client programs, so we'll just ignore it. So again, a conservative collector needs to know how the machine works. It has to step outside of C in order to find stack bounds and inspect registers and look for global variables, all of those things to recognize local and global variables. And again, it's conservative because it has to make some guesses. It guesses that numbers that look like they could be addresses are actually addresses. What happens if you misinterpret a number as a pointer? Then some object doesn't get freed even though it won't actually get used. So you might have some extra objects sitting around that are not actually going to be used by the program. It turns out, experience shows that this is rarely an issue. If you have very long chains, and we have kind of that problem with our tree, then the probability goes up that it will be a problem to hold on to those extra objects. But usually that doesn't happen. A larger problem in practice for conservative GC is misinterpreting a number not as a pointer, but a number that is in fact a pointer, but it's a dead pointer. It's in a variable that's not going to be used anymore in the function. So that level of imprecision is a bigger problem in practice, and what it does is cause a conservative GC to use more memory than a more precise GC might use. Still, even with these problems, potentially mistaking a number for a pointer or keeping a pointer that's not actually alive anymore in the real program, these conservative guesses are often way better than programmers are at manually inserting free calls because things get complicated. So that's why conservative GC is often a good idea anyway.